So I was talking to this friend of mine, and he said, I was listening to the radio in the morning, and I heard about this car that suddenly, on Sand Hill Road, it kind of lifted up and turned around 3 times and ended up in the bushes someplace. That sounds an awful lot like my friend Elon. And I think that was the first time I'd heard about you and speed in the same sentence. And then I got a phone call, and this guy said, I'd like to come up to talk to you in Friday Harbor about this idea I've got. Would you be available for lunch? And you flew up, and that was the first time I'd heard about SpaceX. There may be people in the world who don't know what you're doing. I doubt it. But in that case, Chairman, CEO, and Product Architect of Tesla Motors, CEO and CTO of Space Exploration Technologies, and Chairman and Principal Shareholder of Solar City, the leading provider of solar power systems in California. Obviously, lots of time for hobbies and collecting stamps. So we're going to talk about a lot of things pretty fast today. And I think maybe what we ought to start with is my favorite film from the last 12 months. Okay. If that's all right with you. Yeah. So if those of you who didn't happen to see this, my son and I watched this in real time on the net. That was one of those moments. So let's take a look at this movie.
This transmission is coming to you.
Fuel trim valve actuator set.
You've got it. This transmission is coming to you. This transmission
First stage tank pressing.
Deck 1 triggered.
Water deluge system is on. Vehicle navigation verified.
First stage tank stabilized. Second stage tank pressing.
You've got it. All right, you are go. You've got it.
10,
You are go.
9, 8, 7,
Engine start sequence.
6, 5,
All right, you are
4,
go.
3, 2, 1, 0.
Stage 1.
Liftoff ignition. Liftoff. SpaceX Falcon passenger tower.
Now we see the Earth.
Plus 12.
You've got it.
Pitch kick.
Now we see the Earth. Now, all right.
Plus 20 seconds.
All right.
Plus 30 seconds.
Reducing alpha.
First stage propulsion is nominal.
Vehicle navigation nominal. Gravity turn.
Second stage tank pressure.
We've entered commercial values.
Second stage tank stable. Eco.
You've got it.
Stage separation confirmed.
You've got it.
Bearing separation confirmed.
You've got it. All right. You've got it. All right.
3 minutes and 30 seconds into
Got it.
flight with a relative velocity of 2,800 meters per second and an altitude of 170 kilometers.
This transmission is coming to you. This transmission is coming to you. You've got it. This transmission is coming to you. This transmission is coming to you. You've got it. You've got it.
Thanks. Well, it's certainly nice to come back to fire and actually have gotten to orbit. The last couple times.
Yeah.
We had some.
Took a little
near,
while.
Yeah, we were close. But
Best things in life take a little while. Really, totally cool.
thanks.
So let's talk about that first. We'll start with rockets. Falcon 1, we just saw it happen. First private launch into space, right?
Yeah.
Orbital.
I mean, Falcon 1 is arguably the first fully privately developed rocket to reach orbit. And certainly it's unequivocally the first privately developed liquid fuel rocket to reach orbit. There was the Pegasus from Orbital Sciences, although that did rely on a lot of solid rocket motors that had been developed for the military, so it wasn't 100% private.
No.
Yes, but it's certainly, pretty tough, I have to say. There's a reason why it's called rocket science.
Yeah, right. You've used that line before. So now where do we go? Falcon 1 is going to go again in July, is that right?
Yeah.
Okay, and with what payload?
They'll be carrying a satellite for the government of Malaysia. It's basically an Earth monitoring satellite for monitoring natural disasters like floods and fires and that kind of thing for Malaysia.
Right. And I assume that basically the dream for that part of the program now is just to roll it out, just start doing launches, fill up the calendar with customers, and every how often, do you think?
Well, Falcon 1, I think, will probably initially fly 2 to 3 times a year, and then probably getting up to around half a dozen flights. And then Falcon 9, the bigger rocket, we actually think will probably fly more frequently because it has both it has a larger market that it can access. NASA, space station resupply missions, commercial broadcast and telecommunications satellites, and so there's even though Falcon 9 costs a lot more, the market's actually bigger in terms of total number of launches.
Bigger market.
Yeah.
Okay.
So yeah.
Will you keep using Kwajalein for your Falcon 1 launches?
Yeah. Yeah, and we're actually probably going to build a Falcon 9 launch site at Kwajalein as well.
Really?
To take advantage of the low latitude.
Yeah.
It's at 9 degrees north latitude.
All right. So so everybody understands what we're talking about here. Falcon 1, the definition of one is it's first, and also it's using a single engine.
It's a single Merlin engine. Falcon 9 uses 9 engines.
Right.
Yeah.
And for those of us who are old enough to remember, this kind of takes us back to Saturn V or Delta IV, or some of the big rockets. Saturn V was for the biggest. Is that right?
Yeah. There was a Russian rocket that had more thrust.
Yeah.
But
I mean the biggest American rocket.
Biggest American rocket, and certainly the biggest rocket that ever successfully reached orbit.
Yeah.
The Russians had something called the N1, which had some spectacular failures.
Yeah.
And certainly on certain metrics, the Saturn V is the largest rocket ever built, even bigger than the N1 volumetrically, for example.
Right. I know I told you the story when we were having lunch, that first meeting, but when I was 8 years old, I was looking at the U.S. rockets that were like Falcon 1 and wrote a letter to Werner von Braun that they should all look like Falcon 9 and have all the engines firing at once, right? And don't carry any dead weight you don't have to carry. Get it all done. But he didn't believe in that. The Russians had it, though. The Russians had it. Vostok and some other rockets.
Yeah.
So Falcon 9.
Yeah, Falcon 9 also has the advantage that it has engine out capability. So if there's a malfunction on an engine or even an explosion on an engine, it can actually complete its mission successfully.
You can afford to lose how many? 1?
It depends on the phase of flight. We can lose up to 3 if the third one occurs late in flight.
Right.
And
could put pretty wild stresses in terms of navigation.
No,
right?
we actually in a normal flight of Falcon 9, we shut off 2 of the engines to control G-loading.
Okay. It's that big. It's that good.
Yeah, we want to keep the G-loading, top it out at 5 Gs.
5, all right.
Yeah.
Okay. And what does a human take before he blacks out?
Well, it depends on your orientation. Humans can take very high G-loading if they're flat
in the bed.
Lying on their back.
Yeah.
And if you're in on a soft, something that can conform to your body.
So when you say very high, the number would be?
For short periods, you could take 20 Gs.
Oh, really?
Yeah, for a few seconds type of
Yeah,
thing.
but you wouldn't want to.
You would not. That would not be pleasant.
Yeah, you wouldn't put that in the brochure, really.
No, I think as a general rule, you want to keep G-loading for humans under 5.
Okay.
And that's 5 kind of going into your chest.
Yeah.
Negative, it's much harder to take negative, these sort of eyeballs out.
Yeah, yeah.
G's are a lot harder to take.
We've all seen that. Yeah. Okay.
Like-
So, yeah, the testing. Now, when you go through this, the part of what you're doing with this stuff, it all blows my mind. I mean, it's all just totally impressive. But one of the parts that I like the best, and I know you're Stanford trained.
Not really, actually. I was.
I read the
I never
wrong
actually
thing.
went to Stanford.
We've rewritten that. Okay.
Well, I was accepted at Stanford, and I was going to go to Stanford. And two days into the quarter, I called the chairman of the department and asked to put my grad studies on hold. So I told him I'd probably be back.
It's the Bill Gates approach to higher ed. All right.
Well, it was summer of '95. It was like either I was going to either do my first I thought actually the most likely outcome was that it would fail and then I would be back at school. That was the most likely outcome,
Yeah.
I thought. But it worked out okay.
Okay. I'll skip that part.
Yeah.
But what I was going to say is, even though whatever training you've had, the fact that you could kind of walk into this situation, CTO, right?
Yeah, it wasn't my intention to be the chief designer of the rocket. It just worked out that way.
People say things like that. I don't know what to do with it. I didn't mean to do the atom bomb. It just fell in my lap,
Right. Well, it really wasn't. It's just that I wasn't able to hire anyone, and so I kind of had, I had to do it.
There's
I should
no way
point out,
through this tunnel without just...
Well, I do have very good people in these specific areas of expertise.
Right.
So I have, a great guy who heads up propulsion, guy who heads up structures, another one who heads up guidance, navigation, and control, another one who heads up launch operations.
Yeah. So
but
your job is to manage them, basically, right? To kind of...
Yeah. And so, we've got really good kind of generals, if you will.
Yeah.
But, my job is to say, well, okay, when presented with a few different technology choices in those areas, which ones do we take? Where do we take the risk? Where are the system trade-offs between propulsion structures, avionics? Because sometimes you can make things really easy in one area, but then you make it way more difficult in another area.
It's a
and so I've got to
nonlinear.
arbitrate between those two.
Yeah.
But I know the rocket inside and out. Certainly there isn't anyone that knows the rocket better than I do at SpaceX.
So I'll just say it. It's just because you're so damn smart. There's no excuse for this. There's no other way a guy could do what you just did. You've just
Well, I have high engineering aptitude.
redone the whale or something here. I'm very impressed.
But there's definitely different types of intelligence, and I'm not that smart in a lot of ways.
Well, all right. We'll talk about those later, but you're very good at rockets. So what I was going to ask also is, I assume in your own kind of private lifestyle, as you're going through the original design, the very first iteration of Falcon 1, you finally go through all the heartbreaks and all that stuff, launch it, and you get it done. Your perspective on how to launch a new rocket probably evolves with that experience.
Yeah, absolutely.
And so Falcon 9 comes up, and I see things like, here's the first test of the first engine, right? Here's the first test of the multi-engine. It looked like you're really methodically going through this thing and
Yeah,
trying to
absolutely.
anticipate, which one assumes you would do anyway. So I guess the question here is that true? And describe that process.
Well, for sure, the experience of Falcon 1 is extremely helpful with Falcon 9. And not just that, but also the component hardware in Falcon 9. A lot of that is heritage from Falcon 1.
Mm-hmm. On purpose.
Intentionally, absolutely. So, in fact, the reason we didn't get to orbit on Flight 3 of Falcon 1 was because we decided to swap out the main engine and use the upgraded main engine that would be used in Falcon 9 in order to have flight experience with that engine before we got to Falcon 9. If we'd kept the old engine in there, we would have got to orbit on Flight 3. But the new engine, which is it's a term called regeneratively cooled, which means you use the fuel as a cooling medium you flow it through the chamber and nozzle before it goes into the chamber to get combusted.
It's like a heat exchanger before you.
Yeah, it's like a superheat exchanger. I mean, but it's at a scale that's just not any kind of normal frame of reference. I mean,
And didn't the Russians do that kind
Oh,
of?
sure, and Americans,
Okay,
absolutely.
right.
In fact, that's an example of an error that we made in development, which is that we decided to use initially an ablatively cooled chamber. Ablative just means it kind of burns away from the inside,
right.
like a really hot candle.
Yeah.
And that ultimately that turned out not to be a good path. And so we went regen, and that's been great actually. But one of the nuances of the regen system was that the thrust transient is longer with a regen than an ablative system because you've got some residual fuel in the cooling jacket and it trickles out. And that's the issue that we had with Flight 3 was that that thrust transient ended up being just a few seconds, actually about a second and a quarter longer.
You were firing too long. We were trying to separate, right?
Well, yeah. So as that residual fuel trickles out, and then there's also a little bit of liquid oxygen that's boiling off, you get this very slight residual thrust. It's about 1% of normal thrust, and you actually don't even see it on the test stand because the thrust chamber pressure.
14.7 pounds.
Right, 14.7 psi is sea level.
Is enough to keep it from
air pressure.
Yeah,
right,
yeah,
and the chamber pressure here was 10 psi.
Yeah.
So
an obvious screw up.
Right.
I don't know
So
how I missed that.
we didn't see any issues on the test stand, but when it got to vacuum, that was enough to generate about 1% thrust for a little over a second.
Yeah.
And so we initiated stage separation. There was just a little bit of thrust that was just enough to
keep it together.
Yeah. And then the second stage, effectively, the second stage engine lit indoors, which is bad.
Bad idea. Don't play with matches inside.
Had basically blew 5,000 degree plasma back at the second stage, and fried it pretty badly. Anyway, that's an example of it's a good thing we were able to learn that
Test.
on Falcon 1, and it's not something we need to learn with Falcon 9. And then we've made improvements to the structural efficiency and using some more advanced materials.
Yeah, you put some valves, you put some flanges inside so the fuel would move differently. You had that rotation issue, right? And that got fixed.
Well, we've had so many issues.
Never mind.
There's a lot of issues.
Checklists of.
There was. I'm not sure which specific issue you're referring to, but there's been so many. But
the fuel was moving in a strange way that caused rotation problems on the 2 flight, I think. And there was, just by putting baffles in.
I see what you're referring to.
Right, putting baffles in helped.
On Flight 2, it wasn't the fuel; it was liquid oxygen.
Okay.
But the liquid oxygen tank of the second stage was sloshing, and that the slosh modes, basically the slosh frequency, coupled
you
with
see it in the movie. Yeah.
Right. Coupled with the frequency of the second stage thrust vector system. Yeah. So basically, engine would it sort of essentially kind of fishtailing.
Resonating or something. Yeah.
It fishtailed, and this resulted in kind of a coning motion.
Yeah.
Which actually the guidance system, control system, just merrily sort of coned along along the main insertion vector. And that would have been okay, even though it looked crazy on the camera. Where that became a problem is just as it was nearing the end of its burn, because it was doing this coning motion. The propellant was getting centrifuged to the sidewall of the tank, and so it basically sucked in a helium bubble and flamed out. About a minute before orbit insertion on Flight 2. Yeah. And we solved that problem with the slosh baffles and changing the gains in the second stage control system.
All right, so let's go back to 9. And now you've done the single engine testing in Texas. This is quite an operation. So you've got the Texas. What's it called? The Texas site.
Texas test site.
Yeah. The Texas.
We just call it
test site.
Texas.
All right. and in Texas, you have done the single engine firings, you've done the multi-engine firings. You did the Dragon, recently did the Dragon thruster firings?
Yes.
So, and Dragon is, do you want to describe Dragon for a second? So people know?
Yeah, so Dragon is our spacecraft. So think of, Falcon 9 is the booster that delivers the Dragon spaceship or spacecraft to orbit. And then it delivers it to a parking orbit near the space station. And then Dragon will, with its onboard thrusters, synchronize its orbit with the space station, approach, berth, deliver the cargo, back away and return back to Earth.
Right.
And we developed a special engine for Dragon called the Draco thruster, which is just a little 100-pounder. But you have to have a lot of them because of the fact that you've got to do this.
Careful steering.
Yeah, you've got to essentially dock with the space station.
Yeah.
So you have to have thrusters that are pointing in all directions and are redundant. And you have to have triple redundancy when you're approaching the space station. So you have to be able to lose any 2 thrusters and still be okay.
They don't want a car accidents up there.
Right.
Yeah.
It's pretty hardcore.
Yeah.
And then the flight computers are actually quad redundant. So you have,
Really?
yeah, the quad redundant to avoid you have to have boating. And in order to have 2 failure tolerance against a soft error, you have to have 4 computers.
No kidding. Compared to the old Apollo 13, this is quite something.
Yeah.
Yeah.
Yeah, absolutely. Quite complicated.
And when you land, is it a sea landing or a land landing?
Well, initially it's going to be a sea landing. And Dragon will land just off the coast of California. One thing that isn't sometimes appreciated with what looks like with a capsule type architecture is that it actually is a controlled reentry. It looks like how can you control it because there's no wings, but the way you control it is by having you have a lift vector, so it's about a 0.25 to 0.3 lift over drag, and then you have an offset center of gravity or center of mass. So it's kind of like a tilted cone.
Yeah, okay.
And you can control that lift vector because you can just rotate the vehicle. So you have something it's coming in with a lift vector that looks like this, and then you can just rotate the thing and it'll go that way, or rotate the lift vector, it goes that way. And the rotation is done with the onboard thrusters. And that requires very little force.
So it gives you a lot of control.
Yeah, in fact, even in Apollo, in the Apollo era, they were able to get the capsule to landing accuracy of a 1 mile radius.
Yeah.
And that error was a function of in the IMU, the inertial measurement unit, inaccuracy to some degree, but then also the fact that and wind.
Wind.
Yeah, so we can completely remove any inaccuracy except for wind-related inaccuracy. So if it's a calm day, it'll literally land right down on the numbers. And so we can bring in.
So you've got your boats out there, or is it going to be?
Yeah, our boats.
Davy boats?
No Navy. Navy is expensive.
Well, I thought.
So no, no, there are actually faster ships that we can. Well, actually, we're not going to use ships. I should say for Dragon, it's going to be landing close enough to the coast that we can send a helicopter out to go pick it up.
Okay.
So it's just going to pick the whole capsule out of the water and bring it back to land. And we can use either a Navy chopper or a Coast Guard chopper or a like one of the choppers that drops water on forests, that kind of thing.
Yeah, and I'm just going to mention that from Texas we jump over to Florida, and
Yeah.
you already have a Cape Canaveral site. And this is from Green Fields, right? This is built from.
No, the Cape Canaveral site is actually we've taken over the former Titan IV site.
Really?
So the Titan IV used to be the largest. It's retired now, but
Yeah.
it was the largest vehicle in the U.S. fleet, so it's a great launch pad for us because it's a heavy lift launch pad. Now we don't need a lot of the things that Titan IV needed, such as the big mobile service tower and all that sort of stuff. The way that we've designed Falcon 9 is that it's a horizontal integration. It comes out to the pad, rotates vertical, and then goes. And the design requirement I've said is it's got to be able to go from the hangar to in the air in under 60 minutes. It's going to take us several launches to get there.
Yeah.
But that's pretty tricky because you've got to.
It's only 3 to 5. It used to be 3 to 5 miles an hour on those old machines. I don't know how fast you're moving.
Oh, I mean, ours can certainly go faster than that, plus less distance to cover.
Yeah.
And much less mass.
Yeah.
With the space shuttle, you've got those big solid rocket boosters, which have, they've got the propellant in there.
Yeah.
So it's super heavy.
Right.
Our case is, I mean, the Falcon 9 without propellant weighs about 40,000 pounds.
Nothing.
It's nothing. And it's 180 feet long.
Yeah, right.
You know.
Okay. And the next anticipated, I guess I should insert the COTS thing. So congratulations. We already talked about that once. You got the COTS award. That's still in place?
Yeah, well, more important than the COTS award was an award for basically demonstration of capability. But in December, we were awarded the cargo resupply services contract, which is the operational contract.
And that's what I'm really referring
right.
to. Yeah.
And that's a minimum of 1.6 billion, upwards of 3.1 billion if they fully exercise.
So as Ed Dirksen would say, now we're talking real money.
Right.
Yeah. That's great.
So what that means essentially is that NASA has picked SpaceX as the primary replacement for the space shuttle as far as cargo transport to the space station and back is concerned.
Okay.
So the space shuttle retires at the end of next year, and we will take over it for cargo. The Russian Soyuz will take over for shuttle as far as astronaut transport. But what we hope to get done this year is have NASA ask us to demonstrate astronaut transport as well. So we'll replace the Soyuz, because I think that's really kind of embarrassing that the U.S. would have to rely on Russians.
And you've totally anticipated my next question. So when would be the most likely, earliest manned flight that you would conduct?
Well, it depends on if NASA asks us to do the demonstration, is willing to help us help fund that. If that occurs this year, and there is some money in the stimulus, by the way. So there's about 150 million in the stimulus towards what's called commercial crew demonstration.
Yeah.
Although that's being fought by certain senators. Who
Of course. I won't even ask what party they're from. All right.
Fortunately, they're from the Republican Party.
Right.
We've had some opposition from Senator Shelby in Alabama, which is where Lockheed and Boeing have some very big operations.
Yeah. Yeah. Okay. So you're set to go on all those fronts. Falcon 1 is set to go for July. Falcon 9 is set to go for September, October, November, somewhere in there. One from Kwajalein, one from Cape Canaveral, Building 40.
Yeah.
Hangar. And then we're just going to assume a slight delay in the countdown on 9. It's the first time. And then a successful launch. And when that happens, is it the same story where you start putting 9 on a regular schedule? And
yeah, absolutely. We actually have 21 missions on manifest for Falcon 9.
21. Great.
Yeah.
What's the
So
total
besides
value?
NASA,
Yeah. What's the total value of all those missions?
I haven't added up.
Oh,
I think
come
it's.
on. When you count sheep at night, that's what you're counting, isn't it? Cargo missions.
It's a little over 2 billion.
Okay.
Yeah.
It's another SNS poker chip. So you got 2 chips now.
Right.
4 billion. Pretty good. I'd love to talk about this for 19 more hours, but I see we better very quickly switch over. I'm just going to mention Solar City. Is that going great?
Yeah, it is. Solar City actually, despite the negative economy, tripled its revenue in first quarter, quarter over quarter. Quarter one last year versus quarter one this year. It did 3x its revenue. Now, I mean, they were a little disappointed actually.
Could have been better. Get tough.
Yeah, but I mean, I think I try to tell them like, hey guys, tripling year over year is pretty good.
Yeah.
So they're actually doing pretty well overall, and there's some some improvements to the solar tax credits and all that sort of stuff.
That was good. That worked out right.
Yeah, although those haven't come into some of them haven't come into effect yet. They're supposed to come into effect in July, and so that's going to be really helpful.
Yeah.
Solar City is currently the largest provider of solar power for small and medium-sized installations, basically outside of the utility scale installations in the United States.
Right.
So they're really doing a great job. And,
Yeah. Which I was trying to say in my
Thank
summary.
goodness I don't really spend any time on Solar City. They're just awesome.
Yeah, I mean, you're allocating mostly towards SpaceX, isn't it?
Well, actually, it's about 50-50 between SpaceX and Tesla.
Nice segue.
Yeah.
So Tesla, I guess by now everyone here has either ridden in the Roadster, seen the Roadster, drooled over the Roadster, dreamed of having the Roadster, and let's just do the deal. So you were in Stuttgart 2 nights ago. We all talked about this for the last 2 days.
Stuttgart is lovely this time of year.
I'm glad to hear it. You'll probably see it again. So tell us what happened. What's the deal with Daimler?
Well, yeah, so we've been working with Daimler for about a year and a half on an electric Smart, and they've been a great partner, very easy to work with, and they've got some really good engineers. I think they sort of feel the same way about Tesla, and they actually are quite interested in helping us with the Model S, because they see that as kind of a bellwether for electric sedans.
Yes.
And they want that to be a good car, so that it's not sort of impaired in some way. So they want it to be the best possible car that it can be. And so they're giving us access to the Mercedes supply chain, to engineering and production expertise, because Tesla is world-leading capability as far as electric powertrain. And they recognize that, but where Tesla is not as strong is on the traditional automotive side of things, with the noise, vibration, and handling, and just the things, all the mass production and that kind of thing. So they're going to help us out with that.
And production is a huge new world. I mean, that's just going to mass production. You're into production on the Roadster, but going to mass production is going to be a big deal.
Yes.
Yeah. And you retain the dream of this being a big car company. Is that true?
Well, I think we do want to have, big can mean lots of things. So I think we certainly want to be a serious car company, and have a wide range of models, ranging from sports cars all the way to economy cars and trucks and that kind of thing. I wouldn't want to pursue size for its own sake. I think that's a fool's game. You want to just be focused on making good products, and try to make every product that comes out a little better than the last one.
I'll put it in a different way. When you look at internally at production of the S, what do you see in 5 years? How many cars are you making?
Well, with our third generation, we'd like to step it up by an order of magnitude. So we'd like to be in kind of the 100 to 200,000 units a year.
All right.
With a third generation, and have a price point below $30,000.
Okay, that's a pretty big car company.
Well, among car companies, that's tiny.
It's small.
Yeah, that's microscopic.
Yeah, I understand. But it could go from there to being bigger.
Yes.
Okay.
Absolutely.
All right. We are almost out of time. I want to see the Dragon thing, so we can roll that quickly.
Yeah.
This is you want to key this in? This is.
So this is a simulation of Falcon 9 with Dragon, with the Dragon spacecraft, and I think this is the crew configuration version.
All right.
So.
T-minus 45 seconds and counting. Dragon spacecraft is on internal power. SpaceX is go for launch. 10, 9, 8, 7, 6, 5, 4, 3, engine ignition. We have liftoff of the SpaceX Falcon 9 launch vehicle carrying the COTS-D crew to rendezvous with the International Space Station.
Max Q. Max Q. Main engine cutoff confirmed.
Stage separation confirmed.
Second stage ignition confirmed. Standing by for escape tower jettison.
Escape tower jettison confirmed.
All systems are nominal for Dragon separation.
Dragon separation confirmed.
Ready for approach initiation. All systems are go for final approach.
Dragon is on final approach.
Confirm. Docking is complete. Preparing for ingress.
and I should point out, we can make it land on land, but there needs to be some final velocity attenuation mechanism, such as either having a pneumatic piston pull the chutes just before it lands, like a parachutist would do it, or the Russians use retro rockets. So we can make it land on land. I mean, in fact, you can land on land without that. It just would be a really hard landing. So it doesn't have to land on the ocean.
Gotcha. Before we finish here, give me the quick rundown on the specs for the sedan and for the new Roadster.
So
Roughly, sedan is 5-seater.
Yeah, so the sedan is actually 5 adults plus 2 kids.
Wow.
2 kid seats in the rear, so it's actually a hatchback. And we've done some sort of creative things to get the packaging to work for 7.
Right.
And with the sedan, the battery pack is actually in the floor pan between 2 axles. And the motor and transmission and power electronics are also laid flat just behind the rear axle. So you don't have anything in the front. You've got a trunk in the front and a trunk in the back. So as a result, the Model S has more cargo space than any other sedan, even much bigger sedans. And the rear seats fold forward, so you can have very big things in there. You can literally put a surfboard, 50-inch TV, and a mountain bike in the back seat.
What else do you need?
Right. So it's got tremendous cargo space and functionality. And the trick there was making something that's aesthetically appealing while retaining the functionality. Because you can make something look like a very sleek sports car, but then you start to have sort of supermodel type dimensions, and that your functionality gets impaired. So it was a tough balancing those two things. The standard version of the sedan will have a 5.6 second 0 to 60, which is pretty good for a sedan.
Yeah.
Top speed of 130 miles, range of up to 300 miles.
Really?
Which is
up to 300.
Yeah. So that
with 5 passengers, or with 1 passenger.
Well, probably with 2 passengers. You'd probably be slightly under 300 miles with 5 passengers.
That's a great number.
Yeah. So
charging time?
So 45-minute charge time.
That was huge.
Yeah, 45 minutes is a critical inflection point, because if you travel between cities,
that's lunch.
Yeah, you have lunch, and then your car's recharging in the parking lot next to the restaurant.
Is it a 220, 110?
The 45-minute charge is actually a 400 volt.
440, okay.
Yeah. It
so
actually is the very
special
very
charging
slightly.
Station, or can you bring that with you and convert
no,
it?
No, that would be direct DC directly to the pack.
Okay.
So that would be with an off-board charger. But we actually have that working. We have the high-speed charger working in our lab at Tesla. So there's no speculation. In fact, it's really just a upgraded version of the charger that's built into the car.
You need to have people in various places around the country who are going to have these things where you can charge your car.
Yeah,
right?
absolutely. It's really going to be to the advantage of highway rest stops to have these charging stations there, because they can it'll draw people to go to their restaurants or their their gift shops, and we're going to install some of these for free, by the way. Tesla will do it to sort of get things going and try it out and work out the kinks, and then another thing is we're designing the battery pack such that it can be swapped out in about 3 to 5 minutes.
3 to 5.
Yeah, I mean technically
minutes.
you could do it in like under a minute, but call it sort of reasonably 3 to 5 minutes.
3 to 5 minutes.
Yeah. Well, it's really no different. It's just a big version of what's in your laptop. So how long does it take to switch out a laptop battery pack?
10 minutes.
Well, some laptops, yeah.
Well, that's incredible.
Yeah. So we're not quite sure how whether people will choose to swap out their pack when they're doing cities or fast
charge. You want to do the 45-minute charge? You want to do the 3-minute thing?
Yeah, we want to preserve the optionality. And worst case scenario, it's just an easy service.
Yeah.
So it does require a little bit of engineering effort, but I think well worth the effort. And and it's important to note that you really don't need anything within a city, because if you've got say 250-mile range, your average speed in a city is 25 to 30 miles an hour. So you've got 8 to 10 hours of driving capability per day.
Right.
Why the hell would you need to charge anywhere except your house? Or maybe work. So you don't really need charge stations all over the city or anything like that. It's just between cities where you want to do a distance thing. that you need to solve this problem long term. In the short term, there are other ways to solve it because typically people have more than one car in their household, and so if they've got a gasoline car, they can just basically use the gasoline car for long trips and use this for daily driving. And an important point to make regarding the Model S, and I tried to make this in the Ledman show, and I couldn't get a word in edgewise towards the end there. The important point I was trying to make was that the cost of gasoline is so much greater than the cost of electricity that if you compare our Model S at $50,000 to an equivalent gasoline sedan, you can subtract $15,000 off the price.
Yeah.
And people want to say, okay, well, great, I'm not going to wait 5 years to recover the cost difference. Well, you don't have to, because you'll be able to lease our sedan, and you can lease a gasoline car, and you get the savings from day one.
Wow. So if you're buying it outright, what's the price today?
It'd be $50,000 for this.
And the rebate beyond that?
No, that's inclusive of the rebate.
That's the rebate.
That's inclusive.
And then you get, but
that's inclusive of the federal rebate. So some states have rebates.
And then 35, you're considering gas costs and all that kind of stuff.
Yes.
Yeah. Okay.
But it's like a 5 Series BMW for $35,000. I mean, it's that kind of quality of fit and finish, and actually more functionality.
Fantastic price.
Yeah. So the key, great companies have built in great products. So what Tesla is really focused on is making sure that sedan is just an awesome car, an awesome product. And then we've got some upgrades coming out for the Roadster, which you alluded to. We've got the Roadster Sport, which will have a 3.7 second 0 to 60, and an adjustable suspension. Also, all of the Roadsters, starting in June, will come out with an improved interior, so that you'll have a better interior than the car you tried out today. And there are a bunch of improvements here and there that are going to make it a better car. So.
Really cool. I was just going to say about the S, it looks like you took all the barriers away. You took away every one.
That's the goal. Yeah,
better
absolutely.
distance, better price, financing,
and
batteries.
And a huge part of why Daimler invested in Tesla was the Model S. That was the single biggest factor for the investment, actually.
I would assume that.
Yeah.
All right. Well, anything else we should know about Tesla Motors?
So the electric Smart we're working on with Daimler, the first cars should come out towards the end of this year. It's up to Daimler as to where they deploy those. We're hoping Daimler will allow some of this to come to the US. But there's such high demand for this car that it can be like totally absorbed in any country, basically. There's a huge demand for the electric Smart.
What's their production plan, do you know?
I don't know exactly, but I mean, they've asked us to bid on a very large number. So if that number comes to fruition,
they're ready to go
it's
forward.
a mass production car.
They're ready to go really forward if this
yeah,
works out.
absolutely.
Yeah.
I mean, the economics in Europe, where gasoline is twice as expensive, and the government incentives are even greater than they are here, it becomes an extremely compelling car. In London, for example, you don't pay any, you don't pay the toll fee and that's £10 a day.
Wow.
And
even in the city?
Yeah, going into the city.
Yeah.
And gasoline in London was last summer was $10 a gallon.
Yeah. Obviously.
So they're really, and in Europe you have shorter distances as well. So I'm hoping that they will at least have some allocation for the U.S., but it will easily be absorbed in Europe. And then there's some other vehicle programs that we haven't announced yet with Daimler, a very exciting vehicle program that will probably be announced towards the end of this year.
And just because I have to ask, so the government stimulus money that you've been talking about in public, your hopes for that are strong?
So Tesla actually will not be receiving any stimulus money. The money that Tesla has not received any government funding at all to date. It's a lot of misinformation out there. What Tesla has applied for is a loan under the ATVM program, which is the Advanced Technology Vehicle Manufacturing Program. Congress started writing that legislation 2 years ago and approved it.
Totally different program.
Unrelated to the current economic environment,
Well,
unrelated to the stimulus.
You're right, because I haven't read that in any media.
There's just a lot of misinformation.
Heard it here first. All right. So I totally understand.
So the ATVM program is a $25 billion program, and it's basically a loan program with low-cost loans for the transition from gasoline to electric. And Tesla's applied for just under 500 million, around 465 million. So it's about 2% of the program. The other 98% will go to, GM,
Motors,
Ford, Chrysler,
all those hard driving
I feel
change
comfortable.
agents. Yeah.
Right. I feel confident in saying that of all the people that those loans go to, we will make the best use of that
You get
money.
the most bang for the buck.
I feel confident of
I think you're right.
of that those taxpayer dollars will
Even
be
before you get
well
the money, I
applied.
think you're right.
Yeah. Competition isn't
Okay,
tough.
so and that's going to open the door to the production of the S.
Yes.
Yeah.
We've continued to do a lot of development work on the Model S, although we had to scale back our plans last year and do a layoff because of the economic environment. But we basically last year went from about 30% of our resources applied to the Model S to down to about 10% of our resources, although we've continued to build back up, and now we're back at around 20% of our resources on Model S. With the Daimler investment, we're going to ramp that up. And then with the DOE loan, which will hopefully be announced soon, that's when we'll go into really high gear.
Way up, 60 or 80 or something. That's fantastic. So when we talk about the S, if you had to guess, just guess, when do you see production? When do you see the first car rolling off the assembly line?
It's probably late 2011, so a little, so 2.5 years from now.
Yeah, and you've sold a bunch of pre-orders on the S already.
Yes,
I
over
saw your
1,000.
site. So how many?
Over 1,000. I haven't looked at the numbers in the last week or two,
Very
but
cool.
it was over a couple of weeks ago. We passed the.
What does it take to do
1,000.
this? If somebody wants to get one now.
It's a $5,000 reservation fee, and that basically ensures you get one of the first cars off the line.
If I do 5 of those, I get a Roadster.
Maybe we should have a program like that.
I think we should have a program like that. All right. Well, we've obviously gone over, but I think it's totally worth it. And a couple more things I want to talk to you about. One is, now you've been a stalwart here, and we've been your great supporters. And now that you've got it all pretty much wrapped, it seemed like the right time to invent an award. So we did.
Okay.
And we would like to give you the very first Entrepreneur of the Year award from Fire.
Okay. Well, thanks.
This comes in. So we have Joe. Are you there? So Joe has been nice enough. Joe Sterling, who's well known to anyone from Fire, who does all of our interpretive drawings, as an example of our feelings, has done a special. We'll hold this up. I guess everyone can see it. And it says, it's rather beautiful. It's Solar City, SpaceX, space station. It's got the whole story here. California, Canada, family Musk. Brothers Musk come from other places. So it's your whole life story in one page. And this is for you to put wherever you wish. And then in addition to that, let's see, we want to do a photograph. So if we have, is Sandy here? Okay, I'd like to just shake your hand while we're showing that, and that's it. Okay. Guy to guy, it's like this. Nice job.
Sure.
All right, and one more piece to this, although this is lovely, is how many employees have you got at SpaceX?
We're about 720 or 730.
Okay, say 700. And how many have you got at Solar City?
Like 500, I think.
So we're at 1,200. And how many have you got at Tesla?
400, actually almost 500 at Tesla as well.
So 17, say 1,800 people. Well, I was trying to think of something useful to a guy who's got everything. And the only thing I could think of that would carry value is queuing into SNS. So we're going to give every one of those employees SNS for a year.
Okay, thanks.
Thank you.
All right.